Yes, good evening. Let us start with the next chapter in today's lecture, that is current electricity. Yes, I hope you can see the board. Okay. See here in this chapter, some concepts in 11th standard also are to be covered. ठीक है, वो भी आपको required होंगे actually, क्योंकि current electricity जो CBSE बोर्ड में अगर आपने देखा होगा तो it is just combined. So इसमें जो आपका 11th स्टैंडर्ड में जो आपको हुआ था तो वो प्लस 12th स्टैंडर्ड में जो आपने किया है ऑलरेडी, वो दोनों कंबाइंड ही आपको स्टडी करने होंगे, क्योंकि क्वेश्चन किधर से भी आ सकता है। और एक्चुअली क्वेश्चंस के अंदर ऐसा कुछ बहुत छोटा एक बाउंड्री लाइन है कि कोई कोई भी क्वेश्चन के अंदर 11th स्टैंडर्ड का कोई छोटा कंसेप्ट भी यूज करना पड़ सकता है। तो उसके लिए हम थोड़ा सा डिस्कस करेंगे सब पूरा ही ऑलमोस्ट फ्रॉम द स्टार्ट। यस, so let us start with this chapter, current electricity. See here in this chapter, just wait. Yes. In this chapter सबसे पहले हमको ये डिस्कस करना है Ohm's law and its microscopic form actually, or even we can call it as a vector form of Ohm's law. Okay, vector form of Ohm's law, which is one of the important topic here in this chapter. इसके ऊपर बहुत सारे questions इसके अंदर पूछे जा सकते हैं. So let us see what is the vector form, or you can also call it as a microscopic form of Ohm's law. Okay, so let us see. Ohm's law वैसे broad sense में हमको पता है already कि it is V is equal to I into R, no doubt, where V is the potential difference, I is going to be the current, and R is going to be the resistance, no doubt. But each of these concepts has to be understood. सबसे पहले हमको concept understand करना है what is potential difference actually. If suppose there is a conductor, एक conductor हमारे पास है, metallic conductor for example. Suppose we connect one terminal of that metallic conductor to the another one terminal of the battery, and another terminal is connected to another terminal of the battery. Then we say that the potential difference is created in between these two points. So whatever is the potential difference will give us the electric field in the interior of this conductor. अभी इलेक्ट्रोस्टैटिक्स में हमने अभी जो इलेक्ट्रोस्टैटिक्स चैप्टर किया है उसके अंदर ऑलरेडी हमने ये पढ़ा है कि in case of the conductor, metallic conductor, there is no electric field in the interior. ये हमने पढ़ा है because there are the situation was static, right? मतलब charges was at rest, or the charges were at rest, and that's why there is no electric intensity in the interior of a conductor. But that is not true in case of current electricity. When the charges are in motion, there is a electric intensity even in the interior also. तो इस कंडक्टर के अंदर में भी इलेक्ट्रिक फील्ड होता है, और वो इलेक्ट्रिक फील्ड ही एक्चुअली इलेक्ट्रॉन्स का मोशन कराता है. इलेक्ट्रॉन जस्ट मूव because of that electric field actually. So because of this potential difference between the two endpoints here, some electric field or some electric intensity is produced in this space between the two endpoints of this conductor here, which is directed from positive terminal to negative terminal. we can just show this electric field in this direction, in this way here, by these arrows. And there is a relationship between the length of conductor, the electric intensity in the space in the conductor, and the potential difference. Actually, this potential difference can be written to be simply equal to E into L here. Or we can just say that this E, that is intensity, is going to be potential difference upon length of conductor. ये जो है ये बहुत important relationship है for the intensity here. So intensity and potential difference, both of them are just related with each other by relationship, which actually means that if suppose the conductor is of very large length, ये conductor अगर बहुत ज़्यादा length का है, तो उस केस में potential difference अगर same है, तो उस केस में electric field बहुत weak होगा, electric field बहुत कम पैदा होगा इस conductor के अंदर. और अगर ये conductor का length बहुत छोटा है, और अगर potential difference, same potential difference अगर हमने इस conductor के अंदर अगर जोड़ दिया, तो it will just able to produce a very strong electric field in this case, just because of the length is very short. So the same potential difference produces a very weak electric field in the long conductor, but the same potential difference produces a very strong electric field in a very short conductor. That means there is a inverse relationship between the electric intensity and potential difference between the endpoints of this conductor. So remember this relationship correctly. Okay. Then again, we have the concept of current density here. Current तो हमको पता है already. Current is the rate of flow of charge, no doubt. So we can just find out this current if suppose the charge flowing per unit time is given, or in some cases when the current is not constant, we can just define it as a derivative of charge with respect to time. That is the rate of flow of charge. So here this is the definition of current. Remember. So from this only we can just get this Q. If the current is constant, then we can just this total charge to be simply equal to I into T, no doubt, which is going to be equal to the product of current and time for which the current flows in the circuit. Or if suppose this Q current is not constant, so in that case we can just get this Q to be simply equal to integration of I into dt. Remember, and whenever integration comes into play, we can just relate it with the area under the curve. And if we suppose have the curve of current and time here, current हमने plot किया है y axis पे और time को plot किया है x axis पे, and the graph is like this, then we can just get the area under this curve. If we just get the area under this curve, then we are going to get the charge actually. So charge is going to be actually the integration of current, and current actually is going to be the derivative of charge. If suppose we have a graph between charge and time like this, तो charge हमने plot किया y axis पे और time को plot किया इधर x axis पे, तो and suppose the graph is like this, then the slope of tangent at any point will give us the current at that time. So if suppose we get the slope of tangent at this point, we can just find out the current at that instant of time here in this way. So her tangent, her point पे tangent अगर हम draw करेंगे, so the slope of that tangent will actually give the exact value of current at that instant of time in this way, because it is the derivative actually. तो ये हमको समझना है. This is a graphical representation of this formula that is between current and charge. Okay, now we have to understand this. So we can just say अभी यहाँ पे current को हमने charge के साथ तो relate कर दिया बिल्कुल, but current also have the relationship with the vector quantity called as current density. Remember, whatever is current density is, current density का मतलब क्या होता है? So here if suppose there is a conductor and suppose the cross section of conductor is going to be A, suppose here, then the current density in this overall average in broad sense, the current density is actually defined as the current upon area, or we can just say the current passing through unit area is actually called as the current density. Remember this quantity correctly, current density, which is nothing but the rate of or we can just say the current passing per unit area. मतलब चलो ठीक है, ये अगर 4 square centimeter area है उसमें से अगर सपोज 100 एम्पियर इतना करंट पास हो रहा है, तो हाउ विल यू फाइंड आउट द करंट डेंसिटी इन दैट केस? 1 स्क्वायर सेंटीमीटर में से कितना करंट जा रहा है, उसको हम बोलते हैं करंट डेंसिटी. So the current density is actually the vector quantity, even if the current itself is a scalar quantity. In case when the current density is different at different points, so in that case we can just find out the current density to be simply the di upon dA, where di is the fractional value of current passing through a very small element of area dA. That means if suppose this is the current passing through some area, and suppose at different points the current is different, मतलब अलग अलग पॉइंट्स पे अलग अलग करंट का वैल्यू यहाँ पे जा रहा है. तो उस केस में हम क्या करेंगे, देखो, इफ यू जस्ट ड्रॉ अ स्मॉल एरिया इन दिस डायरेक्शन ऑफ करंट फ्लो, अगर इस करंट के फ्लो के अंदर एक छोटा एरिया अगर हम यहाँ पे ड्रॉ करते हैं इस तरह से, जिसका एरिया सपोज डी ए है, तो इस एलिमेंट में से जाने वाला जो करंट है वो अगर सपोज डी आई है, मान लो डी आई, di is the current flowing through this area, small element of area dA, then the current flowing through that area divided by that area itself will actually give us the current density actually, remember. And because of this only we can just get that current flowing through a small area will actually be equal to the current density into that area itself, dA here. So that means if suppose there is a small area dA and suppose that current density is J in that region, तो उस पॉइंट पे अगर करंट डेंसिटी J है, तो उस केस में इस पूरे एरिया में से कितना करंट जा रहा है वो हमको कैसे मिलेगा? तो वो मिलने के लिए हमको क्या करना होगा, we'll have to multiply this current density with this area here. So just the multiplication of current density and area gives us the current, actual current flowing through that region. इवन सपोज अगर सपोज यहाँ पे एक बहुत बड़ा रीजन है, सपोज यहाँ पे एक पर्टिकुलर इंस्टेंट पे यहाँ पे सपोज करंट जो है वो कुछ और फ्लो हो रहा है, करंट डेंसिटी कुछ और है, यहाँ पे एरिया भी कुछ और है, और यहाँ पे करंट डेंसिटी कुछ और है और एरिया भी अलग है. तो इन दैट केस दिस टोटल करंट flowing through this whole cross section of this conductor as a whole can be obtained by integration. So यहाँ पे करंट जो है, टोटल करंट जो है, तो वो हमको इंटीग्रेशन ऑफ J into dA करके मिलेगा, याद रखो ठीक से. So this integration, why this integration is required? In order to find out the total current through this whole cross section where the current density is different at different points. So we can just take any point and just draw a small circle or small element of area dA around that and find out the current in that area and just go on integrating the currents in each of these areas and just add it finally, so as to get the total current in this whole area. But all these things is possible only when current density is perpendicular to the area itself. But in some cases it may happen that the element of area is in a different orientation. Suppose for example the element is vertical, area जो है वो तो vertical है no doubt, लेकिन current density जो है वो इस direction में है suppose. तो इस केस में ये जो current density है, it is inclined at an angle theta with the normal to this area, which you can call it as dA bar here, in this case dA bar. So in this case we can just resolve this current density in two components and we can consider a component J bar cos theta, which is along the normal of the area, and we can consider that and we can call it as a current passing through that area. So current passing through some area where area vector is not perpendicular to the current density in that case. So we can get this J into dA into cos theta in this case here, which can be written as just the dot product of the current density vector and area vector here. Area vector, which is the vector which is perpendicular to the area itself, remember, and it's all of the same magnitude as that of the area actually. So here this current density, the total current passing through any irregular shape in this case then can be obtained by integration of J bar dot dA bar in this case. Remember this correctly. So this is the most general formula for current, remember, in terms of current density. So here in this case we can just understand why even if the current density is a vector quantity, area vector is also a vector quantity, but their dot product is the current, which is not going to be a scalar quantity. Okay, तो यहाँ पे जो current density vector है, area vector भी एक vector ही है, लेकिन इन दोनों का जो dot product हमने लिया है उसकी वजह से current एक scalar quantity बन जाता है. याद रखो ठीक से. So this is the overall concept of current density here. Okay. करंट डेंसिटी का जो ऐसा यूनिट है तो वो एम्पियर पर मीटर स्क्वायर हो सकता है, याद रखो ठीक से. यस, नाउ वी कैन जस्ट अंडरस्टैंड द थर्ड कंसेप्ट इन दिस सेक्शन, दैट इज अबाउट रेजिस्टेंस. अभी आप बोलेंगे रेजिस्टेंस के बारे में तुमको ऑलरेडी पता है. बिल्कुल, वी नो द रेजिस्टेंस is the ability of the conductor to oppose the flow of current through it. So, but how many of you know that this resistance is actually directly proportional to the length of conductor, and it is also inversely proportional to the area of cross section of that conductor, combining which we get that resistance is proportional ratio of length to area of that conductor. And here the constant of proportionality is actually going to be rho, which is called as the, it is also called as the specific resistance of that conductor, which is denoted by rho here. So this is the full form of resistance. This is the expression for resistance, which tells us simply that resistance R is equal to rho L upon A. Remember one thing here, that the specific resistance actually depends on the material. Okay, it depends on the material of the conductor. It doesn't depend on the length and area. Actually, it is constant for a material. जैसे for example copper. Copper का जो resistivity है, वो उसका खुद का अपना है. ठीक है, that will be fixed in the nature. और suppose we change the material like iron, तो iron का जो resistivity है, वो उसका खुद का अपना है. That will be fixed in the nature. तो nature के अंदर हर एक material का जो resistivity है, वो fixed है. It's not going to change. Resistivity कभी change नहीं होता है. जब तक material हम change नहीं करते हैं, तब तक resistivity change नहीं होगा. For if we get the two wires of same material, that means their resistivity is going to be the same. If we just have those two wires of different materials, then we can just say that these two materials will have different resistivities, rho 1 and rho 2. But जब तक same material है, तब तक resistivity same रहने वाला है. याद रखो ठीक से. इसके अलावा हम ये भी समझ सकते हैं आराम से कि रेजिस्टेंस का जो रेसिप्रोकल है, तो उसको बोलते हैं कंडक्टेंस. So G is defined as 1 upon R. In the same way here, the reciprocal of resistivity is actually called as conductivity, which is denoted by sigma, which is actually 1 upon rho here. So conductance is a reciprocal of resistance, and this resistivity का reciprocal जो है वो conductivity कहलाता है. Again, this conductivity is also the characteristic property of material, which changes only when material changes. Otherwise, it remains constant. Remember. Again, we can see if we just talk about the SI units. तो SI units के बारे में अगर बात करते हैं तो पता चलेगा कि G का जो SI unit है वो होता है MHO. उसको मो भी बोल सकते हैं, या तो फिर ये उसका सिंबल है, और या तो फिर उसको सीमेन भी बोलते हैं. याद रखो ठीक से. और फिर जो कंडक्टिविटी का जो SI यूनिट है, या पहले रेजिस्टिविटी का SI यूनिट क्या है बताओ ठीक से, क्योंकि रेजिस्टिविटी विल एक्चुअली बी RA upon L, right? So resistance is measured in ohm, area is measured in meter square, and length in meter only. So meter square meter cancel होके मीटर बचता है, so इसलिए यहाँ पे आ जाएगा ohm meter as the SI unit of resistivity. But conductivity will have this SI unit which is just reciprocal of this ohm meter. So ohm meter का reciprocal क्या बनेगा? So we can just say ohm inverse meter inverse, or we can just write it as ohm inverse is denoted by mho or Siemen, and meter inverse will be kept as it is, or we can just write it as mho per meter in this way. Yes, so this is the SI unit of conductivity in this way. Okay. So ये conductivity और resistivity के बारे में हमने ये देखा. अभी एक बात याद रखो कि रेजिस्टेंस हो या रेजिस्टिविटी हो, ये दोनों जो है वो टेम्परेचर पे डिपेंड करते हैं। बिल्कुल, रेजिस्टेंस एज वेल एज रेजिस्टिविटी, even conductivity also or conductance also depends on temperature, and the relationship between the temperature and resistance is simply that resistance resistance at T degree Celsius temperature is actually the resistance at 0 degree Celsius into 1 plus alpha T. The reason behind it is that the resistance change in resistance RT minus R naught here is observed to be proportional to the original resistance at 0 degree Celsius as well as change in temperature also. And that's why we can just get this change in resistance to be proportional to the product of original resistance at 0 degree Celsius and temperature change here. And hence we can just introduce a constant of proportionality here, which is denoted by alpha, which is actually called as the temperature coefficient of resistance. It is denoted by alpha, and hence we can just get this equation, which can be converted or expressed in two forms. One is this, already we have got it here, एक यहाँ पे हमको already मिला हुआ है, इस फॉर्म में इसको हम कन्वर्ट कर सकते हैं. If we just take R naught in that side and just take R naught common, then we can get this formula, which is used to find out the resistance at high temperature if the resistance at 0 degree Celsius temperature is given. And we can also express it as alpha. Alpha को हम express कर सकते हैं इस तरह से, which will actually be RT minus R naught RT minus R naught upon alpha, R naught T here in this way. So this RT minus R naught upon R naught T will actually be the definition of alpha. This is the formula for alpha, we can say. Alpha is just the rate of change of resistance per unit resistance with respect to temperature per unit resistance at 0 degree Celsius. इसको हम ऐसा भी लिख सकते हैं, अल्फा इज इक्वल टू ये जो आर टी माइनस आर नॉट है उसको हम डेल्टा आर से डिनोट कर सकते हैं, और ये जो टी है उसको हम डेल्टा टी से डिनोट कर सकते हैं, बट आर नॉट विल बी जस्ट केप्ट एज इट इज. सो 1 अपॉन आर नॉट इंटू डेल्टा आर अपॉन डेल्टा टी, ये भी एक तरह से एक फॉर्मूला बनेगा. और इसको हम ऐसा भी एक्सप्रेस कर सकते हैं एक्चुअली, अल्फा इज इक्वल टू 1 अपॉन आर नॉट इंटू दिस डेल्टा आर बाय delta t can also be expressed as the derivative, remember. So it will be the derivative of r with respect to t, that means dr by dt, which will represent the slope of rt graph. If we have this r and t graph plotted here, अगर हमने यहाँ पे एक ग्राफ प्लॉट किया, रेजिस्टेंस को प्लॉट कर दिया y एक्सिस पे, टेम्परेचर को x एक्सिस पे, and the graph is just like this, then we can just get the slope of this graph to be the slope of this graph to be dr by dt. एक्चुअली dr by dt ये स्लोप बनेगा, और उसको अगर हम r नॉट से डिवाइड कर देंगे तो तब जाके हमको यहाँ पे अल्फा मिलेगा. So in this way, and this graph remains a straight line for a very long range of temperatures, but actually it's curved. ठीक है, it's curved actually. तो ये जो ग्राफ है वो कर्व्ड बनता है, जिसकी वजह से इसका मतलब ये हुआ कि अल्फा विल बी डिफरेंट एट डिफरेंट पॉइंट्स टेम्परेचर्स. मतलब यहाँ पे अल्फा अलग होगा, यहाँ पे अल्फा अलग होगा, और अगर हम यहाँ पे स्लोप और अल्फा को रिलेट करने की कोशिश करेंगे तो स्लोप का मतलब है ये डी आर बाई डी टी, करेक्ट है. सो यू कैन जस्ट गेट दिस स्लोप, एंड दिस स्लोप कैन बी एक्सप्रेस्ड एज अल्फा इंटू आर नॉट. सो द स्लोप ऑफ द टेंजेंट एट दिस ग्राफ हियर, इस किसी भी एक पर्टिकुलर पॉइंट पे अगर हम टेंजेंट ड्रॉ करेंगे और उसका अगर स्लोप मेजर करेंगे, तो व्हाट विल बी स्लोप ऑफ दैट ग्राफ एक्चुअली इक्वल टू, it will be alpha into r naught actually, just because slope represents dr by dt here, which can be expressed as r naught is shifted in that side, so that we get this alpha into r naught to be the slope of tangent here. So in this case we can just get the slope of graph. तो ये जो alpha है, alpha can be found out if the slope is given, or we can find out the slope if alpha is given, slope of tangent if alpha is given. तो स्लोप एंड ये जो अल्फा है, इन दोनों के बीच में ये रिलेशनशिप होता है, याद रखो ठीक से. एंड नाउ दिस रिलेशनशिप, ये जो आर टी इज इक्वल टू आर नॉट इंटू 1 प्लस अल्फा टी, ये जो इक्वेशन है, ये इक्वेशन हम एक और सिंपल फॉर्म में एक्सप्रेस कर सकते हैं. देखो जैसा कि यहाँ पे वी ऑलरेडी प्रूव दैट दिस आर टी, दैट मीन्स द रेजिस्टेंस एट हाई टेम्परेचर is always equal to the resistance at 0 degree Celsius into 1 plus alpha into T. अब यहाँ पे it is not necessary that we must have the resistance at 0 degree Celsius always, but we can just get this formula in general, that resistance at any temperature to be simply equal to resistance at initial temperature into 1 plus alpha into the change in temperature. In fact, this temperature T here will be actually the change in temperature in this case. Delta T, we can just replace it by that. So here this formula can also be put in this expression in terms of resistivity. If we just divide this everything both sides by, देखो यहाँ पे जैसा कि हम जानते हैं कि R2 into A upon length L. Here also R1 into A upon length L. If you just multiply here and 1 plus alpha into delta T is kept as it is, then we can just get this R2 into A upon L to be replaced by density at that temperature. Rho 2 we can say. Sorry, density nahi. Sorry. क्या बोलते हैं उसको? Specific resistance, or we can say resistivity at high temperature, rho 2 here, which will actually be the rho 1, that is the resistivity at low temperature, into 1 plus alpha into change in temperature. Remember, this is the formula to find out the resistivity at high temperature if we know the resistivity at low temperature, any case. And even this equation can also be expressed in terms of resistance, conductance also, and conductivity also. तो कंडक्टिविटी के फॉर्म में एक्सप्रेस करने के लिए सिर्फ यहाँ पे प्लस के बदले माइनस आ जाएगा, यूजिंग द बायनोमियल अप्रोक्सीमेशन. You can use the binomial approximation and get that here this rho 2 can be replaced by 1 upon sigma 2, that is conductivity at high temperature, which will be 1 upon sigma 1, which is the conductivity at low temperature, into 1 plus alpha into delta T, so that we can just cross multiply and get this as sigma 2 to be simply equal to sigma 1 upon 1 plus alpha into delta T. Okay, this will be the expression for alpha sigma 2, that is the conductivity at high temperature if we know the conductivity at low temperature in this case. And even we can just express it in this way, sigma 1 into 1 plus alpha into delta T the whole raised to minus 1. But as we know that 1 plus x raised to n is approximately equal to 1 plus nx when x is very, very small than 1. So in this case, we can just get this sigma 2 replaced by sigma 1 into this minus 1 will just jump here in this between the two terms. And we can get this finally as 1 minus alpha into delta T as the final. So this is the relationship between the conductivities at two different temperatures, remember. Okay. Yes, this is the relationship between the resistance and temperature in short. Okay, then again we can just see now we are in a position to understand the microscopic form of Ohm's law, or we can say vector form of Ohm's law. See, सबसे पहले हमको एक कंसेप्ट डिफाइन करना पड़ेगा, ठीक है? उसको हम बोलेंगे नंबर ऑफ इलेक्ट्रॉन्स डेंसिटी. रिमेंबर, number of electrons density. What does it mean actually? See here, suppose there is a conductor. This is suppose the conductor of length L and area of cross section A. Okay, so there will be the atoms in between here. Here suppose atoms hai. Okay, these are some atoms. Remember, I'm not talking about electrons but atoms. Okay, so abhi agar suppose मान लो कि we want to find out the number of electrons density. So number of electron density can actually be defined as the number of electrons per unit volume. Here V is nothing but volume here. So we can just denote it by VOL, because V will just denote it by potential difference ना. V हमारा V जो है वो potential difference के लिए reserved है, इसलिए number of electron density define करने के लिए number of electron density is denoted by small n, which is defined as the total number of electrons per unit volume. So if suppose there is a conductor and suppose that it is a sodium metal, okay, sodium metal conductor है. So in this case, we can just know that if we all consider all these atoms are of sodium metal, then we know that every atom has one free electron. सोडियम के लिए क्या होता है, एक एटम का एक इलेक्ट्रॉन फ्री हो जाता है. ये सपोज फ्री इलेक्ट्रॉन है, ये फ्री इलेक्ट्रॉन है. So per atom only one free electron will be there, and because of that we can just see that these free electrons will be available for conduction, and hence the number of these free electrons per unit volume will actually be called as the number of electron density here in this case, okay, which will be very small in this case. But as compared to this, if we consider the magnesium, if you just consider magnesium in place of sodium here, so magnesium के बारे में हमको पता है already, it has 2 electrons per atom free. So इसलिए ये जो magnesium, ये सारे atoms अगर magnesium के हैं तो उस केस में per atom 2 electrons free electrons will be obtained here. So these are the 2 electrons free electrons. These are the 2 free electrons of this magnesium atom. These are the 2 free electrons here. These are these 2. So in this way, so we can just see that per atom we are getting 2 free electrons free in case of this magnesium. So if we just see overall, ये पूरे वॉल्यूम के अंदर अगर हम देखेंगे तो सोडियम के कंपैरिजन में जरूर डबल नंबर ऑफ इलेक्ट्रॉन्स फ्री रहेंगे, obviously, because sodium gives only 1 free electron per atom, but magnesium gives 2 free electrons per atom. And if we just talk about aluminium, then we can just say that there are 3 free electrons per atom. So if this whole concept, or if this whole conductor is made up of aluminium, अगर ये aluminium का वायर है तो हर एटम का 3 इलेक्ट्रॉन्स हमको फ्री मिलेंगे. ये देखो इस तरह से, ये 3 इलेक्ट्रॉन्स इस एल्यूमिनियम एटम के हैं, ये 3 इलेक्ट्रॉन्स इस एल्यूमिनियम एटम के हैं. हर एक एल्यूमिनियम एटम क्या करेगा, 3 इलेक्ट्रॉन्स प्रोवाइड करेगा, free electrons, right? So these are the free electrons provided by aluminum atoms, and these free electrons will not just remain along with those atoms. Actually, they will be free to move anywhere in this whole conductor, and that's why we can just define the number of electrons per unit volume to be the number of electron density. Okay, so electron density कैसे हम निकालेंगे? So it will be actually the number of electrons, total number of electrons divided by the total volume of that conductor. If suppose we consider the total number of electrons to be n, which is very complicated and we cannot find it out easily. Okay, so n is going to be the number of electrons in this whole particular conductor, which has to be divided by the volume. What is the volume of this conductor? This conductor is in the form of a cylinder, right? So what is the volume of cylinder? We know already that the volume of cylinder is given by the product of area of base and length, right? And hence we can just multiply this area and length together so as to get this volume here, and this will be actually the formula for number of electrons density, so that we can just express this total number of electrons in this whole conductor to be simply in terms of number of electron density as n a l in this way here. So this is the formula for number of electrons. Okay, if a is the area of cross section of this conductor, L is the length of conductor, then we can just get the total number of electrons in that conductor to be simply number of electron density multiplied by area into length of conductor. That's it. Yes. One more concept is here called as the drift velocity. See here, what is drift velocity actually? In rough sense, पहले हम उसको roughly define करेंगे, उसके बाद हम आगे जाके समझेंगे कि actually what does it exactly means. First of all, we can just consider all these electrons when the potential difference is applied across the end points. Suppose this is the negative end and this is the positive end. Suppose these terminals of this conductor are connected to the opposite charges, so that the potential difference will be created in this here. So all the electrons will just start moving in this direction, correct? So all the electrons will start drifting from this negative end to positive end, because they are attracted towards positive charge and they are repelled by the negative charge. And so the effective velocity of electrons to move from this point to this point here will be called as the drift velocity, which will be denoted by Vd here in this case. How will you define this Vd here is, if suppose we consider that the time required for this electron to start from this point and move this whole distance is suppose t. Okay, so t is the time required for the electron to move from this point to this point. Then we can just have this drift velocity to be simply defined as the distance traveled by the electrons, that is the length of conductor, which is divided by the time required for the electrons, okay, to move from this point to this point here. Yes, so this is the basic definition of drift velocity. It's very simple. The drift velocity means velocity of electrons, which is the distance traveled per unit time by the electrons. So it will be calculated by the total distance traveled by the electrons, which is L, which is equal to the length of conductor here, and that is to be divided by the time taken by the electron to move from one point end point to another end point of the conductor here. So this is the concept of drift velocity. Now we already know that the current is actually equal to the charge upon time, correct? Hai? So here we can just get that charge Q upon time is the current. If suppose this charge एक चार्ज को यहाँ से लेके यहाँ तक क्रॉस सेक्शन तक क्रॉस करने के लिए अगर t इतना टाइम लगता है, तो उतना ही टाइम जो है वो इस इलेक्ट्रॉन को यहाँ से लेके यहाँ तक मूव करने के लिए लगेगा जरूर. So if you just consider the whole charge, total charge in this conductor to be capital Q, which is actually going to be the number of electrons, capital N, multiplied by electronic charge here, that is to be divided by time t here. So ये करंट जो है, तो करंट को हम इस तरह से एक्सप्रेस कर सकते हैं, total number of electrons into electronic charge upon time, क्योंकि charge itself is going to be the number of electrons into electronic charge. So here this formula can also be expressed in this way: I is equal to E into number of electrons passing per unit time. So ये जो ये n upon t जो है, ये एक important concept है. इसको हम बोलते हैं number of electrons crossing per unit time. Okay, number of electrons crossing per unit time, which can be written to be simply equal to number of electrons crossing per unit time can be written to be I upon E. Okay, so remember this correctly here. This number of electrons crossing cross section of the conductor per unit time, मतलब एक सेकेंड में कितने नंबर ऑफ इलेक्ट्रॉन्स क्रॉस करते हैं एक पर्टिकुलर पॉइंट को, that will be obtained by just dividing I by E. इन शॉर्ट ये हम देख सकते हैं आराम से. और ये इससे भी आगे जाके अगर हम यहाँ पे ये जो I है इसको n इंटू ई, इसमें n का जो वैल्यू हमारे पास ये ऑलरेडी है यहाँ पे, तो वो अगर यहाँ पे रिप्लेस करते हैं तो n के बदले हम डाल देंगे यहाँ पे it is going to be small n into a into small l, and that is to be multiplied by e and to be divided by t as it is here. So then we can just be able to get this as I is actually equal to n kept as it is, a kept as it is, e also kept as it is, and l is to be divided by t here. Okay, so length of the conductor is to be divided by the time taken by the charges to completely cross this whole cross section. Okay, so ये जो L upon T है already हमने यहाँ पे निकाल के रखा है, it is going to be the drift velocity. So from this only we can just get the relationship between the current and drift velocity. Simply n is I is equal to n a e into Vd, where I stands for the current and the n stands for the number of electrons density, a is the area of cross section, and E is going to be the electronic charge, and Vd stands for drift velocity here. Even we can just take this area of cross section in the denominator in this other side, so as to get this as I upon a to be simply equal to a e simply. But as we know already that this area current upon area actually happens to be the current density, right? Current density उसको हम बोल सकते हैं. So here we can get the direct relationship between the current density and drift velocity. That is current density is equal to a e into sorry a कहाँ से आया, a तो नीचे चला गया ना, So A will be in the denominator, and here it will be I upon A will actually be equal to N into E into VD actually. And now if we just replace this I upon A by J, which is called as the drift velocity, then we can just be able to get that J is going to be equal to NEVD, which is again a new formula here, which is a relationship between the drift velocity and current density actually. So here, these are the number of formulae which we have already derived here, which are worth important, very important. Okay, all these formulae are very important in this case. And then after remembering or after learning all these formulae, we can be able to understand the microscopic form of Ohm's law, or we can call it as a vector form of Ohm's law. Okay, which we will do it tomorrow. I think all these formulae are very very important, and we have to almost देखो ये पूरे derivation के अंदर हमने जो देखा हर एक step मतलब एक formula है. It is not a derivation actually I have solved here. ये कोई derivation नहीं है, हर एक step मतलब एक formula है, क्योंकि तुमको देखो पूछने के लिए कुछ किसी भी फॉर्म में पूछा जा सकता है. Maybe that sometimes the drift velocity will be given and length of conductor is given and time is required, or maybe it happened that the number of electron density is given, area length is given, and number of electrons, total number of electrons in that particular conductor is to be found out, or maybe charge is given, time is given, and current is to be found out. No doubt. Even sometimes it happens that the number of current is given, इलेक्ट्रॉनिक चार्ज तो ऑलरेडी तुमको पता ही होता है 1.6 into 10⁻19 होता है करके. So you may be asked to find out the number of electrons crossing per unit time, okay, through the cross section of the conductor. So even ये भी करंट दिया हुआ है, सपोज नंबर ऑफ इलेक्ट्रॉन पर यूनिट वॉल्यूम दिया हुआ है, एरिया दिया हुआ है, एंड ड्रिफ्ट वेलोसिटी निकालने के लिए बोला है. इट्स ओके, वी कैन जस्ट फाइंड इट आउट. और ड्रिफ्ट वेलोसिटी दिया हुआ है एंड करंट निकालने के लिए बोला है. All these things are maybe given, so we can just find it out. और current density is to be found out. तो एरिया भी देने की जरूरत नहीं है फिर उस केस में, अगर सिर्फ नंबर ऑफ इलेक्ट्रॉन का डेंसिटी दिया हुआ है और ड्रिफ्ट वेलोसिटी दिया हुआ है, तो we can be able to find out the current density easily in this case here. So all these formulae are to be kept in mind so that we can just solve MCQs. Okay, so आज के लेक्चर में हम इतना ही सब करेंगे. तो नेक्स्ट लेक्चर में लेकिन हम ओम्स लॉ का जो माइक्रोस्कोपिक फॉर्म है तो वो हम स्टडी करेंगे, डिराइव भी करेंगे, और उसके ऊपर जो फॉर्मूले बनते हैं तो वो भी हम लर्न करके रखेंगे. ओके, सो लेट अस स्टॉप दिस लेक्चर हियर. थैंक यू ऑल ऑफ यू.